Welcome and thank you for joining us today. My name is Paul Donahue and I will be your host. We ask that you keep your device muted during the session. And if you have questions, please direct them to me via the chat function. We'll do our best to answer them at the end of the session, and anything that we don't get to, we will answer via email. As I think you all know, these tech talks have been designed to provide insights into radio frequency components, some of the related technologies, and the design and engineering value added by a custom manufacturer such as TRM. Today's Tech Talk is going to focus on multi-layer PCB technology and the various pros and cons associated with different design features. To share the details, I'm once again pleased to introduce TRM's Chief Technology Officer, Shaun, the author of 2 U.S. patents and a number of white papers and technical articles on passive microwave technologies. Shaun has been with the company since the late 90s. As I like to say, his passion has only increased over the years, especially when it comes to solving customers' design and engineering challenges. So welcome, Shaun. Would you like to start maybe with an overview of today's session?
Yeah, thank you, Paul. I certainly would. So basically, multi-layer technology for PCBs can really manifest itself in several ways. And with any technology, you know, there are positive points to the technology, and then of course there's always the drawbacks. Some of the things that when we look at here, as far as with PCB technology and really any technology at all, is that you clearly have pluses and minuses with every sort of technology. The discussion today is really going to focus on embedding passive microwave components in a multi-layer assembly. I'm not really going to focus on what happens if you build a multi-layer board that is used just for routing, power and those sorts of power and signal, for just a complex system. Really, we're going to focus on passive microwave components that are embedded into PCBs.
Okay, well, maybe you could elaborate a little on the pluses and minuses, possibly starting with the advantages.
Certainly. So as with any sort of passive microwave component, there's always some element of craftsmanship involved with it. These are the subtle details working with any kind of distributed circuit technology, really to make sure that that the PC shop fabricates and develops what it is that the end circuit needs. One of the advantages of having a multi-layer PCB assembly for these sorts of distributed elements is that really you're now in a machine-based manufacturing. Therefore, there's less craftsmanship in putting that assembly together. That is primarily true of once we go between layers of the PCB and within the assembly. If we have plated through holes, for example, along with ground vias and circuit vias that have that transition as a machined base manufactured system, it's much more consistent than if you have a manual system. So really, especially for the interlayer vias, traditionally in a multi-layer assembly that is not in a bonded assembly, we have the transitions are made of wires. We have dielectrics made up of Teflon beads going through machined housings to act as transitions between these layers. With a multi-layer PCB, all of those transitions now are machine-based. Variation is really reduced dramatically. And in addition to that, those sorts of structures lend themselves to very accurate simulations within a lot of our software analysis tools, such as HFSS. So those sorts of things are very, very positive. The other thing also is that once you have a board level design that has all these interlayer transitions designed right into it, you can now have a very clean launch off of boards that are made to be surface mount components onto its carrier or motherboard. So this way here we can get a good, reliable, and predictable sort of transition. Again, if we're talking about the older style of having machined housings, the launch between that subassembly and and where it's going really depends on that sort of mechanical interface. And there are far more variables in that kind of interface as opposed to going to a direct solder mount. One other good advantage here is that you make very good use of your material. You can etch large numbers of these on a single panel, and if you did your design correctly, these parts once they're fabricated just work. There's no tuning involved.
Okay, well, how about some of the disadvantages then?
Yeah, and the disadvantages has a list just about as long as the advantages, as with any technology. Heading up the list is actually the positive thing that you don't have to tune these things is also a negative. You can't tune them. So in that case, really you have to make sure that your design is centered. That also drives to a lot of the performance requirements as far as to what you have available to you. You really have to go in there and make sure that you work within the manufacturing tolerances to make sure that the performance will land within what the manufacturing tolerance will actually yield. A lot of customers really try to push passive microwave components to teeter on what is physically possible, just for general physics. In which case, a lot of these subtle manufacturing tolerances cause parts to actually go out of spec. So with a multi-layer PCB technology, you have to take that into account, which usually means that you have to loosen the spec up a little bit to make sure that you have good yields. You're really, like I said, when you get into these sorts of devices, those sorts of things really drive it. The other thing also that you have to bring into account now is that you're no longer dealing with a pure microwave material in a mechanical stack-up. You're now dealing with some sort of a bond ply or a glue layer that is actually being part of the dielectric stack-up. So as a result, the loss tangents of those materials need to be taken into account. Again, that adds a little bit of insertion loss over a traditional microwave stack-up that is in a compression. From a fabrication standpoint, things that start making the etch a little more critical when we talk about getting multi-layers stacked up. This is things that the PCB industry does a reasonable good job at. However, it's something that you just can't ignore, especially when you're getting via structures that are running several layers thick. The interlayer registration becomes very critical, especially from an RF standpoint. The relationship of the active vias and the ground vias, you form virtual walls within these sorts of structures, and having that whole interplay work really just need to be very, very cognizant of the tolerances involved as you're doing the design. Can be very successful. Again, typically you have to loosen up your requirements a little bit from an overall performance standpoint to make sure that you have good yields. Otherwise, you could be generating a lot of scrap, which isn't really good for anybody.
Okay, well, that certainly makes sense. Are there ways, Shaun, to manage the disadvantages or to modify the design so we could still be able to seize upon the pluses?
Absolutely, and really, I think a lot of the advantages within a multi-layer PCB has to do with control of vias. That is a tremendous benefit. It's been my personal experience that as we're building up these assemblies, those transitions and the variation in the hand craftsmanship of those transitions really drives performance. So by taking advantage of those machine-based via structures is absolutely huge. I think that is absolutely a very big benefit of multi-layer PCB technology. The the downside actually has to do with controlling some of the etch tolerances. The PCB industry does a pretty good job, and they can etch down to a mil or so as far as what they actually guarantee. For a lot of coupled structures, a mil isn't good enough to make sure that we hit our the windows that we need for coupling and those sorts of features. So if there's a way that, for example, and TRM has done this, where we have certain features that are on the top and bottom layers of that stack up, that gives us accessibility to it to tune for those little bit of etching variations. and therefore give us the opportunity to make those fine adjustments for the cases where we have really tight electrical performances. Again, if we can work with the customer and make sure that, to accommodate those edge tolerances as part of the design, that's a better than. However, there are some systems that, quite frankly, just can't tolerate it, but they would benefit very much from the other benefits of having a multi-layer structure. So if we can, like I said, for those sorts of applications, I think it's very appropriate to design the part where we have access to those sorts of features to make that final adjustment as needed.
Well, as usual, lots of good information, concisely delivered. Can you summarize?
Sure. So basically, multi-layer technology, it's been around for quite some time. Use in the RF industry is becoming more and more prevalent, especially when we're talking about embedding passives into PCBs. The sort of technology really has a lot of benefits, especially for controlling the impedances of vias between layers. It also can save money. If we're embedding components into a PCB, we no longer have additional items that are on the bill of materials. Therefore, we can save some material costs for some of those other little bits and bobs that have to go in there and get put in there. For certain applications, if we're talking about a fully embedded structure, we lose the ability to tune it. Therefore, we have to go in there and make sure that the tolerances work with what the final requirements are. And if for some reason the requirements can't be loosened up and we still need those really tight requirements, taking a second look at that structure and see, is there a way we can design that product with some feature that's on the outside of the part that will allow us to be able to have that last little tweak. We can go in there and improve the performance and get the final performance that we need. There's also especially if you're dealing with a surface mount style component, really working with a customer interface to make sure that the interface of the passive component that's meant to be put in as a surface mount component interfaces well with the carrier or the motherboard that's being mounted to. That interface is all very critical. It's just as critical as the connector to launch interface on traditional sorts of components, and should not be trivialized. It's an important thing to make sure that both parties are on the same page. Very often when you work between a multi-layer technology and the carrier, you're dealing with different substrates, different materials, different thicknesses, line width changes at that transition. So those sorts of details are something that really needs to be considered, need to be worked out with the customer as the design is being done.
Okay, well, thank you. And what are some of the unique things or differentiators specific to TRM with respect to this technology?
Yeah, sure. So, TRM is as I like to say, a solution provider rather than a person where you just go and just with a shopping list and say, here, let's buy some of these parts over here. We have those parts, happy to sell them. However, really what we like to do is like to work with our customers to make sure that the solution that we're providing is indeed the best solution for their customers' needs. We want to make sure that we remove those pain points, whether it be the way we design our parts, the way we select our materials, the way we package them. And really, I think also a big part of one of our advantages is the fact that we are quite happy to supply whatever data or objective evidence that is needed to make sure that the part will be successful at the next higher assembly. So really working with our customers, making sure that they get not only the hardware that they need, but also make sure that they get the data and the objective evidence to show that this part will continue to function in the environments that our customers are putting it into.
Excellent. And we did get a couple of questions. I think we have time for at least one. The question is multi-layer technology limited to surface-mounted applications?
Absolutely not. I think when most people think about surface mount technology really and multi-layer passives. They think about these small little drop-in devices that that you can buy, that you could then just go ahead and just solder onto your board, and you can add a coupler, you can add a power divider for a nice embedded solution. However, at a much larger assembly, you could actually embed these devices directly into whatever circuit that you're building. And for larger networks, that is certainly what TRM does. We have a lot of very sophisticated networks of power dividers, couplers, and hybrids that we build into a multifunction assembly. A lot of beamformers are built that way, for example, where it's all in one PCB. All of these functions and all of these various individual components are actually built on the same PCB as part of a multi-layer network, where we use vias and bonded PCBs to be able to build a full-up assembly and a full-up subsystem embedded into a single PCB. So the thought that really it's limited to single drop-in devices, that can be a very effective approach for some people. Other times you may want to actually do the integration all in a single multi-layer PCB, and that is something that TRM has been quite successful with.
Excellent. Well, thanks again, Shaun, and thanks to all of you for joining us. If you are a customer and you have more questions, or if you'd like to discuss details with one of TRM's engineers, we'd love to hear from you. Please feel free to call the engineering hotline. The number is on your screen, 888-677-6877. Clearly, there's no cost for these calls. Now, if you're one of our field sales representatives, then you know your calls are always welcome, and you can also submit questions directly through the sales rep portal on our website. In case it's helpful, the next Tech Talk will be set for October 25th at 1 p.m. Eastern Time, with the topic to be announced shortly. Thank you again, and thank you, Shaun.
Thank you, Paul.